Lesson 2 covers applications and problem solving. In Chapter 1, Section 4, I'll be translating words into symbols. Take a moment to look over these phrases that translate into their respective variable expressions. Notice 5 less than a number is written as that number minus 5 and not the other way around. For example, 3 less than half of x is written as half of x minus 3. Half the difference between x and 3 is written as the difference between x and 3, and then half of that. 5 less than the quotient of a number and 8. In case you forgot, here's a reminder of a bit of math terminology. That's x divided by 8. 5 less than that, minus 5. That's my answer. The question is asking how many calories are in a fruit salad that consists of 1 apple, 2 peaches, and 1 banana in terms of peaches. I'll start off with peaches. Calories in 2 peaches would just be 2p. An apple has 29 more calories than a peach, so 1 apple represents a peach plus 29 calories. A banana has 13 more calories than an apple and 29 more calories than a peach, so a banana's calories equals a peach's calories plus 42. This variable expression represents the equivalent amount of calories in terms of peaches as this fruit salad.
I'll be translating sentences into equations. 11 less than twice n is 7 more than n. That would translate to 2n minus 11 equals n plus 7. I have a game here. I'll be matching the equations on the right with the sentences on the left. I recommend you push yourself to match the equation with the sentence before I do. 3 less than twice a number is 8. That would translate to twice a number minus 3 equals 8. That equals E. 3 times the quantity 2 less than x is 8. I would start with the quantity x minus 2, multiply that by 3, and that equals 8. A is my answer. 2 less than the product of 3 and x is 8. The product of 3 and x, 2 less than that, equals 8. B is my answer. 2 times the number, which is 3 less than x, is 8. The number 3 less than x is x minus 3. 2 times that equals 8. F is the only one that satisfies that. 3 times 2 decreased by x is 8. That one I can translate in order. 3 times 2 decreased by x equals 8. That would be D. 3 times the number, which is x less than 2, is 8. The number 2 minus x, 3 times that, equals 8. C. 3 diminished by twice a number is 8. 3 minus 2x equals 8. That's G. 2 decreased by 3 times a number is 8. And this one can be translated directly. 2 minus 3x equals 8. H is my only answer.
My objective is to write an equation involving x with the given information, including the area equals 10 units squared. I know the area of a triangle equals 1/2 base times the height. Therefore, the area of 10 units squared equals 1/2 the base, in this case x, times the height, times 5. The question does not say to solve for x. It just says to write an equation in terms of x, so that is my answer. Part A says to choose a variable to represent the number described by the words in the parentheses. So I will define the first number as A. Part B says to write an equation that represents the given information. The sum of 3 numbers equals 120. The second number equals 8 less than the first number. The third number is 4 more than the first. Now I can substitute A minus 8 for B and 4 plus A for C. Again, the question doesn't ask me to solve for the first number. It just wants an equation, so that's my answer.
In Chapter 1, Section 6, I'm translating problems into equations. And here's the game plan for doing that. Notice it doesn't specify to solve the problem. This chapter is having me practice translating problems into equations a lot because extracting equations from the problem is typically more difficult than solving for the variables. Step 1 is read the problem carefully and figure out what is known and unknown. Step 2 is to choose a variable. I let j equal Joe's amount, therefore 2j equals Lynn's amount, based on the first sentence. Step 3, reread the problem and write an equation. Again, I'm not solving for how much Joe and Lynn have. I'm simply writing an equation, so that's my answer. Let h equal the height of the building, then 3h equals the height of the tower. The tower is 50 meters taller than the building. That's my answer. We don't know the weight of Ling, her suitcase, or her knapsack, but we know 3 facts that relate those weights to each other. Here I'm letting k equal the knapsack weight, and I've written the suitcase and Ling's weight in terms of the knapsack weight. Keep in mind that I could have written the knapsack's weight and Ling's weight in terms of the suitcase's weight, or the knapsack's weight and the suitcase's weight in terms of Ling's weight, and still end up with a valid equation. If you reread the problem, the knapsack's weight is the only item that isn't described relative to another item. That makes it the easiest variable to start with. The knapsack plus the suitcase plus Ling's weight equals 170 pounds. And that's my answer. The cafeteria served twice as much milk as apple juice. So half the milk served equals the amount of apple juice served. If there was 3 times as much milk served as fruit punch, then a third of that amount would equal the amount of fruit punch served. The total amount of milk, apple juice, and fruit punch served equaled 660 cartons. And that's my answer. Just to check for understanding and ignoring the equation, were more cartons of apple juice or fruit punch served? Can you confidently tell me that more cartons of apple juice were served than fruit punch? If converting apple juice and fruit punch cartons in terms of milk isn't straightforward, consider drawing a picture to help you understand what's going on. Add the last 2 steps now that I want to solve the word problems in section 7. After reading the problem, I drew a little sketch to help me better understand this problem. The question is asking for the car's distance, so I will set my variable to equal the car's distance. The bus traveled 318 kilometers further than the car. From the second sentence, I gather the car traveled 1/3 the distance the bus traveled. I distributed 1/3 to get 1/3 c plus 106 kilometers. After subtracting 1/3 c from both sides, I get 2/3 c equals 106 kilometers. Multiply both sides by 3/2 to cancel out this 2/3, and I get 3/2 times 106 kilometers, which equals 159 kilometers. If the question asked for how far the bus traveled, I would add 159 kilometers plus 318 kilometers to get 477 kilometers. A rectangle and a square both have the same width. Sides of a square are equivalent. The length of the rectangle is 5 meters longer than the length of the square. I know the total area is 133 square meters. Instead of adding the individual areas and setting it equal to 133 square meters, I simply push them together because they have the same width. That way I can take the area of the entire shape. The area of this rectangle equals length times width. The length is 2x plus 5 meters times the width, x, and that equals 133 square meters. In Chapter 12, we'll learn how to solve for x in this quadratic equation. For this chapter, we'll plug in our choices and see which one is true. X can equal 6, 7, or 8 meters. After plugging those values into the equation, I got these respective values. As you can see, the only equation that is true is when x equals 7 meters.
Thanks for watching. If you liked my video, do me a favor and click subscribe. If you'd like to be notified when I upload subscriber challenges, turn on notifications.